Okay, everybody has something up there that says portable power stations.
Yep.
Okay, so this is upon special request. Ted has been relentlessly bugging me about talking about portable power stations. So I said, what the heck, I'll go ahead and provide a program here. So this is kind of an excerpt. I do another program on emergency power. And so this is a part that gets plugged into that program. That program that I do is a 2 hour program for people that are trying to um, think about providing emergency power when the lights go out. So topics we're going to hit on is, what's emergency power? What is a portable power station? What is one? And fundamentals of watts and appliances. So uh, like any kind of this is a lot of stuff I do, I turn things into an engineering project. So I think as an engineer, and it always starts off with a set of requirements. So I need some way of sizing what I'm trying to do. So I need to know about appliances, how much power they consume, and be able to add those things up. And we add that power consumption up in watts. So we'll talk about what's inside a portable power station, and these devices are getting more and more popular. Actually, for 7QP, we had several people that brought along their own personal portable power station, which was really, really cool. So we'll talk about sizing of these devices, how to use them, things to consider when using. So, in other words, the portable power station um, doesn't tick all the boxes. It does a pretty good job, but there are other things that we need to consider about a personal power station that it may not tick a particular box. And at the end of everything, we got to think about how this fits into ham radio and how we might use it, or maybe some of the challenges. Any kind of technology that we go after, it's never ever a absolutely perfect fit. There's always something that doesn't quite fit right, or undes there's undesirable consequences that come along with some of the things that we use out there. So we'll talk about that. So we all know that during the year we're going to have some power outages. Some of them last just 30, 40 minutes or an hour. Some of them last for days. So, but always kind of gets disrupted. We need to figure out. You need to ask yourself about how much disruption can you tolerate before you come up with some alternatives on providing yourself power when you can't get commercial power. So we also know that power companies are becoming more and more risk adverse. Whenever we get really, really hot and dry, windy days, they are likely to shut the power down. And it's easy for them to shut the power down and thereby mitigate the potential of coming up with some undesirable consequences and starting forest fires. But when it comes to turning power back on, power company has to go back through there and inspect all of the lines, all the power lines that were de-energized, make sure that they are safe and no damage has happened to them before they re-energize. So a simple 1 day power outage from the power company can yield 2 to 3 days of you not getting any power before they can get things turned back on by the time they get finished inspecting all the power lines out there. So another anomaly that we kind of have is about every 7 and 13 years, we always seem to have some kind of a real major event out there that ends up knocking our power out for quite a while. So one of the things that we get around here is ice storms. That can come along, and I live in a rural area, and that power outage, we can have something between 5 to 7 days without any power. So when you start getting out that long, it means that kind of needs to think about looking at some other way of getting some alternate power. So thereby, one of the things I've done with this, another program that this fits into, is talking about other ways that you can generate electricity to keep your house operational. So we know that where we live in, eventually, and who knows when that eventuality will be, we're going to get a substantial problem that can affect the power grid for a very long time. If we get something like our subduction zone earthquake that ends up ripping up our coastline and ripples up through the Willamette Valley, we're likely to have not have any power for a substantial amount of time. Maybe weeks, maybe months. Who knows? It may end up approaching a year, but you can have a long, long time without any power. So, three questions here. When you start looking around for emergency power, extra sources of electricity, um, you know that none of this comes free, and it always helps if you do a little planning. You know, if you have a major power outage, that's the wrong time to do any planning. You need to do your planning before you have any of these major problems so you can have everything in place to be able to handle not having electricity. So, three questions you need to ask. So, how long are you willing to be without electricity? You know, some people can't stand to be without having their fix on Facebook for a day. So, they got to be able to have electricity within a day to get them back on Facebook. Other people, it may be 2 weeks. If you're an old guy like me that's not on Facebook, you could care less. But I do need my electricity to take and run my ham equipment. So when you do have a major outage and you don't have electricity, what kind of creature comforts do you really need in your house? What do you need electricity for to live? And you really need to think about how much discomfort you're willing to go for. Some people can't stand any, so they are willing to buy or step in and buy a whole house emergency generator. That's extremely expensive and also costly to operate. But you have all the creature comforts you need. You have all the water. You have all the um, um, heating, cooking, washing clothes, everything that you take in a shower, everything. But that's pretty substantial. So, but there's, for most of us, there's some kind of place in between on what we absolutely have to have. Then the bottom line is that looking at those top two, the one next one is how much money are you willing to spend to maintain your comfort level? So if you establish your comfort level, how much is that going to end up costing? Figure out what type of machinery or appliances you need to keep operational in your house. That really defines how much money you're going to have to spend to take and give you that comfort in living. So those are three really, really important questions there that you need to look at. So this is the only technical slide that I have. Um, but when we're going through and evaluating uh, what we need to keep working, we're talking about appliances. We're talking about hot water heaters. We're talking about microwaves. We're talking about, um, maybe heating our house. Um, talking about TV, lighting. So all of those appliances take electricity. So once you've kind of figured out your minimum needs, you can take and start adding up how much these various appliances take. So let's start at the very top here and walk through kind of the bullets here. So I'm just picked an average size house of around 30 square feet. And all these numbers in here, they're generalizations. They're not absolute numbers, but in real world, they're fairly close. So let's just pick a 2,000 foot square house. You normally have a 220 service that comes in. It's a 200 amp service that can yield a possible 48,000 watts of energy. So we know that watts are a combination of volts and amps. When we multiply the two together, we end up with watts. And so that's a good measurement that we can convert from either 120 volts or 220 volts, 240 volts. But it's an easy way of adding up what our um, appliances will consume. Another common term is kilowatt hours, kWh. So um, when we take a look at a large consumption rather than taking just looking at watts, we typically convert that into kilowatt hours. So that's 1,000 watts of energy being consumed over 1 hour. So that's an important terminology to remember there, kilowatt hours. So an average U.S. home uses, and this is assuming you don't have alternate fuels such as propane or natural gas that is feeding your house. This is considering just an all electric house. If you have um, propane or natural gas, you're probably going to be using that for heating the house and for your water heater, for your gas range. Those are the kinds of appliances that you're going to be typically use. So this number will come down. But for an all electric house, you're going to be using about 30 kilowatt hours per day, per day. 30 kilowatt hours per day. So that's a pretty good amount. So one thing to remember was you're adding up things for your appliances. If you have any type of a device that has a motor on it, anything that has a motor on it, to get that motor starting to spin is going to be take between 2 to 3 times more energy than its active um, power rating. So we need to consider what we have as far as surge protection or surge power when we start up motors, like you start up your heat pump, there's a compressor that has to start up. That has a factor of about 3 times more energy to start the thing. So you always start off with figuring out what appliances you absolutely have to have. Well, some people can't live with a coffee machine, without a coffee machine. So you got to have coffee in the morning. Well, normally it's like 750 watts, but it means that you probably only run the thing 10, 15 minutes once a day, and that's what you get. So you can take that 750 watts if you run it for 10 minutes, divide it by take your 750, divide it by 60 times your 10 minutes there, and that tells you how many watts you're going to end up using. Um, You can probably get away without running your dishwasher. That's a big eater. You might end up using your microwave for cooking all your food. So you'll probably want to add that in there, but you're not going to run that all the time. And the same formula I gave you before, you can figure out how long you end up um, actually running it for actually cooking your food. And also, you can even use it for doing your coffee. You can boil your water and then do your drip on your coffee on that. Um, so anyway, it goes through there and gives you a list of things that are, that you're going to use there. A couple things to on the right side there where we talk about air conditioning. Remember there that that compressor there is probably going to have 3 times the amount of energy that it takes to get it going. So you have to count that in on your budget on things. So this is just one list that I kind of threw together. Um, you can do a little web searching and you can come up with nice lists like this, which gives you the starting factor. So you see this number in that center column there, that's your multiplication. So the numbers that you have there, like your refrigerator, 750 watts, to get that little compressor started, it's going to be about 3 times that. So that's going to be for a second or two to get it going, and then after that, it'll drop down to your 750 watts. So anyway, you can find all these charts all over out there uh, on the internet. That'll help you come up with an estimate. Also, your all those appliances, if you dig around, there's going to be a sticker on them. It tells you how many watts the thing is actually going to end up you consuming. So you can look at the nameplate or the product plate on it, and it'll give you the numbers on what you want for watts. So you add all this together, and then you figure out what you need to take and run your house. So a typical 2,000 square foot house, I said that it gives you about three kilowatts a day. To replace all the power required by your house, you need to take inventory of every single electric devices in your house. Well, that's not really true. Now, if you're going to replace all of it, you go to your power meter, you go through there and get out there at 8 o'clock in the morning. You write down a number on what your power meter is. The next day, you go out there at 8 o'clock in the morning. You write that number down again, subtract the two. That gives you what's going on. But if you're only going to try and power part of the house, then you do need to end up come up with an inventory of that. So, big question is that do you really need to run all your appliances in your house at one time? No. You need to think about how your house works. You're not going to be running your clothes dryer all the time. You're not going to be running your water heater all the time. It has a cycle rate. My water heater comes on usually around 7 o'clock in the morning, does a nice preheat, grab our showers, and then by 8 o'clock, then it goes back to sleep. Then I turn it back on at about 5 o'clock in the evening, and then for washing up dishes, and then it goes back to sleep again. So, you can figure out what your duty cycle is on your appliances and apply that to it and figure and use that to build your budget. So, if you're a survivalist, there's 5 things that you need out there. You need heat, some way of staying warm in the house. You need water. I consider you need a refrigerator because whatever food that you have, you need to keep it refrigerator or else it turns toxic. For me, I gotta have my refrigerator because it keeps my beer and pizza cold. So that's an absolute must-have. Microwave, it's pretty easy for me to just connect my microwave up to a generator and uh, warm my food, cook it, whatever I need. That's enough to keep me going. Need a little bit of lights, some lights in the house. That really helps. People that may have a CPAP machine or other medical devices, you need to consider that too. But I don't need a whole awful lot. Uh, the things that I really need, somehow I need water, and people you can get away with, stockpiling water, and you can usually get by with 2 or 3 days of it. But after that, you got to do something to take and flush your toilet. So you really need main, some substantial amount of water, unless you use the trees outside. I talked about the refrigerator. I like to have a little bit of light on. If I have a little bit of light on, I like to keep the wife happy, so I like to have the TV on. So those are the 3 main things that I need to have in my house operating. So let's talk about one of the neat little products out there. I'm not talking about gas generators. I'm not talking about other kinds of devices or a Ford Lightning truck providing electricity for your house. We're going to be talking about these little portable power stations. And we'll talk about how they work, what's inside of them, how they scale, cost to them, and how well they end up working and what they do for us, and different configurations that you can get for them. So inside that box, it's so what they've really done is gone through a process of packaging and come up with a really nice package. So inside that box is a battery. There's an inverter. That inverter takes that battery power, that DC power, battery power, converts it into AC 110 that we can use for our appliances. Means that we're going to be using power from that battery. That battery, the what's stored in there is going to eventually get depleted, and we need some way of charging it. So there's a battery charger in there to take and restore the battery back to its full charge state or state of charge. And then there's usually some outlets on the front of the box. And then there's a bunch of other uh, optional stuff that you can get in there. So they have the ability to add additional batteries or battery banks for more storage. So you can take a base unit that maybe has a 100 amp hour um, lithium battery in it, and they have the ability to add more and more of these batteries onto the device, and thereby extending its range or its output for additional time. Now, generally, it's not going to give you more output because that base unit, there's this guy here, is going to, if it's set, the max it can get produce is maybe 20 watts AC. That's usually about what it's going to give you, and it's not going to give you any more. 20 watts AC, it may last you a day. Now, if you want it to last 2 days or 3 days, you're going to have to add more of these extra battery banks to this thing to get it to last longer. Some of the units have the ability to do solar charging. They make that a big deal. But as we get into this, we'll understand what that really means for this kind of device. How, so I'll throw it in now. So right now, you'll find most of these units are a lot of these units are equipped that where you can connect solar panels. It gives you about um, 200 watts of power to of solar. Now we know that if you have an absolutely perfect day, you lay your panels out and you track the sun, a 200 watt set of panels is really going to yield you between 160 to 170 watts max. It's not going to give you a true 200. We know that during the summer we got good long days, but if you're trying to take and recharge 100 or 1,000 watt battery, that's going to end up taking you basically about 6 hours of really solid sunlight to recharge it. Now, if you have a bigger unit and only 200 watts charging it, it's going to take a lot longer. Now, we're also talking about perfect conditions. Let's change that when we have a disaster. You need this thing. We're talking about winter, not summer. Summer, we have tons of solar power here, but during the winter, we have a really, really low angle that sun sets at. You're going to be lucky, and we only during the winter we get about at best 3.5 hours of usable sun, and that sun is so low, and we always have lots of clouds. We have rain. It's not cool, but we're going to be lucky if we can get 6% out of that solar panel. Now you can imagine if you only get 6% out of that solar panel, how long is it going to take you to take and recover 1,000 watts out of a set of 200 watt panels that is only getting 6%? Long, long time. So for us that lives in the northern climate, those solar panels don't always yield the best solution. Now, having said that, one of the things that you can do is that, okay, they say that it will take a 200 watt panel. During the winter, you can add more. You can add 1,000 watts worth of panel. That gets a lot of, that gets pretty expensive. And it can probably get you up to, during the winter, maybe 200 watts worth of usable energy that you can put back into your battery. So just throw more money at it, but you have to consider, is it really worth it? So anyway, in the winter, solar energy really sucks. You're always battling there trying to get any kind of energy out of those panels based on our climate and our the low angle of the sun getting into us. So I mentioned about adding a second parallel power station, so you can add you know, you have to, every manufacturer, every unit is a little different. Some of them you can add three, some of you can add five, but you can always add more devices. You also have the ability where a lot of these um, power systems don't only provide you 110, doesn't provide you 220. Uh, some cases you can add two of these battery packs or power systems, little control cable that connects them back together, and you can have one side giving you 110, the other one giving you 110, connect them together, and bingo, you get 220 out of that. You'll get your single phase 220 out of that. So you can get 220 of them. When you get into some of these bigger packs, it will naturally give you 220 out of it. Another nice management feature is some of these units, as you get into bigger, better ones, have a management system that'll either work using a Wi-Fi or Bluetooth. But all of this, none of it comes free. There's always a price to it. So as we're looking through specs in these units, there's a list of things that we want to look at, while we're evaluating it to see if it gives us a good fit. We want to look at capacity. That's about how much energy this battery pack will provide for you. So it's typically expressed in watt hours. Output. So this is the number of amps that it will give you. So there's maximum sustained output in watts. The second thing you want to look at is surge. I mentioned that when you have an electric motor that starts, it can eat up 2 to 3 times its operating needs. So when you're starting some kind of electric motor, you want to take a look at what it has for surge capacity, and you kind of want to look at what um, how long it can last too. Some of them are milliseconds, some are 2 or 3 seconds. You really want something that's in the like 2 to 3 second category to get a good solid electric motor up and spinning and working right. So, but that's the surge. You want to look at that for your motors. So we talked about all the ways we get power out of that battery pack or out of that system. We need to think about how we charge it. We take power out. How do we get power back in it? How do we bring it back to life again? So if you have something that has 1,000 watts worth of capacity, you're spinning off 100 watts an hour. That's going to last you for 10 hours, and then you got to recharge that thing. 100 watts is not a whole lot. It's pretty easy to eat that up if you're not being very judicious on what you're using for power. So you want to look at your charge rate. How much time does it take to recharge the battery to restore it back to a um, uh, fully charged level? And that's always expressed in hours. So a lot of these you'll see it's anywhere from 2 hours to 3, maybe 5 hours to recharge it. But that means you have to have some way of being able to connect the device to some other device that's providing AC, like a generator, or your commercial power has been restored. You can connect it to a source uh, from your commercial power to restore the energy. The other thing you want to look at is that, I mentioned before, we talked about solar charging. You want to look at the charging rate from a solar panels. In other words, you have uh, it'll tell you that, it's only good for 200 watts. That means the charge controller is only going to produce 200 watts or convert 200 watts of energy going into the battery. And you want to see how fast it's going to end up to recharge that battery. You also have to pay attention where your solar charger is going to be, say, the maximum amount of voltage that your PV voltage that it will take. So if you have Your normal 100-watt panels, normally those are 22 volts each. You can add them together. A lot of your low-end solar chargers are good for 50 volts. So you can run two of those things in series. That's just fine. And you also need to look at the max number of watts that it will take and pull off your solar panels and put back into your batteries there. And so that'll give you the uh, the amount the charging rate. So normally that's expressed in hours. And then you also want to look at the weight. You'll find that most all these things are pretty reasonably in weight. Matter of fact, very, very reasonable. The only time you start getting into higher weight levels is when you get into really big stuff. So here's an example, and this is kind of a minimalistic. So I have a refrigerator, and I talked about duty cycle. Normally, when that thing is running, it's 750 watts, and then it also um, has a starting factor. But I didn't use it, but I just derated the 750 watts to what I thought was a reasonable duty cycle. So I say I'm going to use 200 watts out of that. TV, anywhere. I mean, we've got a big TV, so well, I think most people have pretty good size. So you're going to be sucking between 60 to 100 watts for your big old flat screen. If you want to look at a little tiny one, you can save some energy. You have lights on in the house. Um, I just put down 120 watts. Most all my stuff is all converted to LED, so that may be a little bit overkill, but that came up with 420 watts. So I'm going to be consuming 420 watts on average through my house with just these three items running. So let's look at some real world examples. So in this one here, there's Blue Eddy, Jackery. There's Heinz 57 varieties. I'm not saying any one is any better or any worse than other. I just decided to let's so I can keep the view of what we're doing and the numbers and stuff consistent with what Jackery and people love Jackeries out there. So I have a low end, medium end, and a high end Jackery. And let's look at the specifications on what this guy does. So this Jackery 1000 has a price tag of a little less. You can get it a little less than $500. It has a capacity of 1,070 watt hours. Um, has output. It can produce 1,500 watts. So that'll run your air dryer and run most any, I mean, by itself, it can take and run a microwave by itself. It also will provide for surges up to 3,000 watts. Not bad. So once the thing gets discharged, if I want to plug it back into AC and recover the thing or a generator, it's going to take a little less than 2 hours to bring it back to life. Has the ability to, I can run uh, 200 watts of solar into the thing, and I don't remember the specs on it, but it only weighs um, about 24 pounds. So like a good sized set of groceries, a bag of groceries. So that means using my 420 watts, this little guy is going to last me for about 2.5 hours. Not very long, not very long. So that probably wouldn't be a good solution for me if be fine if I only expect to be out of electricity for an hour or two. But for a full day incident, that's not very good. So let's move up to the mid series. That's a Jackery home power system 3000, around $1,200. Has a capacity of 3,072 watts. Output surge 3,600 watts. The surge on that is 7,200. So can put out some pretty good power. If you notice that that has a 30 amp RV type of plug on that. So if you're RVing, that you could take and run this guy here and let it provide for your RV pretty nicely. So to recharge the thing is a little bit greater than when you plug it into AC, a little greater than 2 hours. Solar power, 200 watts, pretty traditional. It weighs a bit more, so it brings into at 60 pounds. So that's like a good bag of manure out there. So that's pretty heavy. So in my example, for that 420 watts that I need to run my three appliances, that's basically 7 hours. Still only 7 hours. I can't even make it a full day, even with this guy here, with just those three appliances. So let's talk about a big dude, kind of top end. Home, the Jackery Home Power 5000. So just for the base unit there, so I have the lower right, I have a picture of the base unit there, and the guy on the left there is the um, auxiliary, the extra power packs that you can plug into this thing. So the base unit is a little less than $3,000, has a capacity of about 5 kilowatt hours. Pretty good, but that still feels a little on the slim side. Um, Output 7,200 watts, 1,400 watts surge. This guy can also produce 220. Over on the right-hand side, it has a plug for 220. No, left-hand side, it has a plug for 220 you can plug it into. Charging time is a little less than 3.5 hours, so you can plug it back into an AC source and get it recharged in about 3.5 hours. Not bad. It's a nice thing about lithium batteries. It does is really charges up fast. Whatever amount of power you have, that lithium battery will just pretty much consume it straight away. So this guy is expandable. So I mentioned that the thing was good for about 5 kilowatt hours. So you can expand this up to 60 kilowatt hours. That's by adding a second one of these Jackery main units, connecting them together. That produces 220, and it can provide you up to 60. So in other words, that's more than, I mean, if you were running your full house. Now, there are limitations. You're not going to be able to take and run all your big name appliances all at one time. There is a limitation to how much this guy will end up putting out. So you have to end up staggering what you end up using at one time for your big appliances. But each one of those power packs adds an extra 5 kilowatt to the system. They cost around 2,300 bucks per little box there. So by the time you get, if you rent two of those plus five each, that'd be 10. Anyway, that makes my head hurt. A lot of money to get this thing to scale up for a full house. So solar capacity. This guy has the ability to use large commercial panels, big dudes. You can have up to 135 PV volts. So these are many number. This would be like four commercial panels in series to get you up to that kind of voltage level. So you can run lots of solar into the thing. The base unit itself, 135 pounds. It's on wheels. It has a handle that you can tilt and roll it around. So it is pretty nimble, but it is a lot of weight there. So just that base unit, here again, running those three devices, I'm still only get around 12 hours out of this. So if I want something that's going to run me multiple days, um, like a week or something, I have to have some other alternate power source to recharge these devices, such as a gas powered generator to take and recharge them. This particular, the low end and medium end the amount of solar is peanuts. If during the winter, it's not going to meet your needs to recharge it. This guy here has the ability, the whole house one, the 5000, has the ability to take a lot of solar to recharge them fairly quickly. Things to consider. So I'm getting down to wrapping things up here. So a large power station will not allow you to run multiple large appliances in parallel. You're going to have to take and run them in just one at a time. So you're not going to be able to run your dishwasher and your clothes dryer and your air conditioning all at the same time. You're going to have to sequence that. During the winter, or a very large powers of, or a very large power station, 200 watts of solar just is not going to be adequate to recharge your power station. It's more of a, to me, it feels more of a sales gimmick than something realistic. During the summer, yeah, you can get it to work. It'll recharge it. But you have to remember, if you're only putting, you know, 150 watts in on solar, and you're busy pulling 400 watts out on just running your three main appliances, you're at the point of diminishing returns. You're going to have to turn off those appliances to let that recharging cycle take place. For extended power outages, okay, you will need to recharge your power station. So that means if you're going to be going multiple days or something, you're going to have a generator there or something like that to recharge it if you don't have commercial power going on. So, and also don't, yeah, there's, let's see if I left this slide in here. Yeah, here we go. Here's a interesting slide here for equals something. Yeah, EcoFlow. There we go. So many of these guys, they advertise their systems being able to plug into an outlet on your house and running your whole house. It ain't going to happen. It may happen for a few hours, but it's not going to happen for over a long period of time. So let's see. So it's just not realistic that you're going to be very successful in one of these big systems, except, you're going to plow a ton of money into it to get to the point where you're going to be able to run your entire house. And still, compare this to maybe a whole house generator, you might very well be better off with a whole house generator. Okay, so let's think about as a ham. How do these play into hams? Seems like a pretty neat device to be able to take out to the boonies, be able to plug in to have a nice AC outlet, run your normal old 12-volt power supply, run your laptop that likes 110 volts, and you're going to be all well and happy. So the one thing that you need to remember, what's common about inverters, battery chargers, solar chargers, they all use switching technology. You all have devices in there that is turning power on and off, running through a transformer, and then taking the output of the transformer to run your device at whatever electricity, whatever frequency, whatever um, mode you're using. But they all have inverters. Every one of those devices make electrical noise. These devices are extremely noisy, and I have not at this point in time seen anybody come along with any empirical information that tells us about devices that don't make a lot of RF. They all generate RFI. So beware of that. And I guess I mentioned earlier that all these devices are made up inverters, batteries, and solar chargers. So we know that Victron really produces a clean system. You can go on DX Engineering. They have some inverters on there that they stipulate that are really, really noise free, really low. Now you pay for them, but you can find inverters, and I suggest taking a look at DX Engineering. Give the technicians a call. They'll help you to walk through it and make sure that it meets your needs. These inverters have FCC type A and B certifications for RFI, and that's what you want to look for any type of device that does any kind of switching. So let's wrap things up for, oh, here's another example. Um, so a transceiver, let's say you're running single sideband at 100 watts, get, that basically consumes about 40 watts an hour there. You have a laptop, that's good for about 50 watts an hour there. That gives you 90 watts worth of power. So a Jackery 1000 with 1,000 watts of capacity, that's going to get you probably about 11 hours worth of run time out of it. So that's probably, I mean, that's ideal and great for like doing soda and stuff like that. But you have to also deal and think about what that RFI. And I don't mean to give this a big black eye, but um, just buyer beware and know what you're doing. I always say, when we're out doing 7QP, we're setting up on top of a mountain. And why on earth do we have an S3 and an S5 noise level going on? There's something out there that's making a lot of noise that is preventing us from listening to and connecting to weak signals. That means you have to have signals above that S5 before you can even talk to them. So let's go through kind of a summary and wrap it up here. So, me as an engineering, I always start with requirements. What the heck do I want to accomplish? How do I want to accomplish it? And so I kind of stipulate requirements. So I need power when I don't have any commercial power. Well, I also need to stipulate how long I'm willing to go without that, or how long I need this power to last me. So I need to understand those limitations and what it means as far as what I'm going to select for equipment. So you do some math on your storage and how much you're going to have to kind of estimate on how much you want. You could do a penciling on what you think you're going to want to spend for a budget. And then you start the process over again and work out, come to figure out what you're going to select for equipment, how long you're willing to go without power, and how it's going to meet your budgetary needs. Usually, your budgetary needs are the least flexible thing. Everything else moves around to it. So you go out and do your research. Go look at all the different manufacturers, look at reviews, figure out what works right. Make sure it has the features that you want. Make sure you're not paying for stuff that you don't want, but you got to do your own research out there. So you end up selecting the properly sized portable power station that you want, and you push the buy button. And 2 to 5 days, it shows up in your front doorstep. So, any questions on what I talked about there?
Thanks, Mike. I saw a couple of applications. In any of those units, can you run just off the battery, assuming that it's 12 volts without the inverter, such that you can reduce the noise down?
Yeah, um, I saw some of those features in the better ones and the higher end ones that allows you just to tap into the battery. But understand that that battery in there is not normally a 12-volt battery. That's normally a 24 or 48-volt battery that they're running so they can get better efficiency off the inverters.
Hmm,
So it's not always native that they run the 12.
gotcha. Thank you. I was just thinking about field day and other things where you could use it, you know, in
Yep.
a dual mode.
Hmm.
Mike, one of the things that comment on the 12-volt output on those is they're limited to 10 amps,
Well,
which if when you're transmitting a 100-watt transmitter, you're going to be over 10 amps.
yep. Yep. Yeah, very good point there. Yeah, is that when you start using the smaller ones, you got to pay attention to what each one of those orifices, what each one of those outlets, and how much power is going to give you to see if it meets your needs. Anything
Mike,
else there?
Mike, I'd like to share one little thing about my home system here.
Yeah.
So I'm going to steal the screen. And again, this is just just because. Let's see, share.
Yep. You have an awesome system there, but you rolled a ton of money into it.
Yeah, content. Let's see, is background share. Let's see if that works. Okay, are you seeing my screen? So let's see here.
Pretty blank at the. There we go. Now we got it.
All right, so here is my generator. And the generator, if you can't see it, has three different outputs. So I have the economy of choices here. There is an outlet here for propane. Don't worry about this little adapter here. That's just for whatever. But there's the propane plug. And if I think this is the propane inlet. And using these numbers here, you can see if I run on gasoline, I get more output. If I run on propane, I get 8450, and if I run on natural gas, I get 6900. But I have to show you this. This is I need to give you the aspect. Right here is a 40-gallon trash bin, okay? Because it looks like just a giant propane. It looks like a propane tank with a close in. This is 100 gallons of propane.
Yep.
100 gallons, not 100 pounds, 100 gallons. And we have yet to hook it up yet, but you can see it's staked down. It's staked down into the yard here for earthquake resistance. And so this is our plan for doing just that. The other thing I wanted to share, which Mike was alluding to, was this is what I have in the RV. I have about 80, I think I just did the math, 8,300 watt hours. And what Mike said was, there's the battery unit and plus additional batteries, similar to the Jackery, only a different brand name. I've chosen the 8,300 watt hour solution, and it takes a 30 amp, a 50 amp, or multiple 20 amp inputs. And in it, you can either charge it with a generator or you can charge it with solar, not quite at the 1,000-watt level like you talked about, Mike. I think the Jackery has it beat on that. I think I can go to 750 or something like that.
Yep. So anyway, those devices they have their place, but beware that you may end up having some issues with RFI, and that's where I keep coming back to. Yeah, there's some neat things that they do there, but or am I better off just buying my own battery, buying my own inverter? Thereby, I know what that inverter, as far as what type acceptance or what FCC regulations it meets as far as emissions. Am I better off going that direction? And same way with the whatever charging device.
Thanks, Mike. Always informative and gives us something to think about when we're designing our system for both either portable use or for backing up our home AC systems.
I got one more question. So Ted, are you happy with what you got?
Yes, I am. I was going to mention that I ran my system, a station, completely off of the Bluetti, and I detected no RFI on my radio.
Beautiful. Good.
Awesome. Thank you for that, Ted. You saved me some testing. Okay, any other questions for Mike before we go on to the next part of our meeting here?
Thanks, Mike. That was good.
Yeah, always.
Welcome.
And just a quick nod to Field Day coming up soon. We'll talk more about that coming up in the agenda here. But talk about portable power. I mean, that's what Field Day is focusing on, right? Portable power, using your station outside of normal operating procedures. So, excuse me, normal operating power. You either generate it or bring it stored and deplete it or use solar power or something else?